Okay, so welcome back. I'm recording now. This is week 13, class number 1. One thing some of you might notice is that like this slide that I'm sharing is about single replacement reactions. If you've done your lab already, you've already looked at this. Now I helped the people I had in my lab kind of cover this subject, but really it's a pretty straightforward concept that we'll review today and tomorrow, single and double replacements. So okay, let me backtrack. We've already done combination or synthesis, we've done decomposition, and we've done combustion, hydrocarbon combustion specifically. So right now we'll look at single replacement. So single replacement is when a single element replaces an element from a compound. Really, that's it. One important thing that a few students really got confused about on Monday, or sorry, Sunday, today is Monday, on my Sunday lab, is that you have to make sure that metals replace metals and non-metals are replacing non-metals. And we're going to practice this today. I just had a question about the final exam. I'll mention that after this class. We'll talk about the final, but I did mention the information about your final on Wednesday. But we'll come back to your final on at the end of class. Good question, but just remind me at the end to talk about that. Okay, so back to this single replacement, one element will replace another, but specifically metals replace metals, non-metals replace other non-metals. Okay, so in the lab, when you guys did this, you did an experiment to see if the reaction happened or if it didn't. So when a reaction happens, you see color changes, precipitates, bubbles, light, heat. How do you do that on a test, or more specifically, how would you do this on your final exam if you're not in the lab to do the experiment? Well, luckily for you, or maybe unluckily, we have this information provided for you in your data booklet. Your data booklet has something called the activity series. And the activity series will tell you if the reaction happens or not. Not every single replacement will happen. And this is because not all elements have the same amount of activity or reactivity. In simple words, sometimes it just won't happen because it doesn't want to happen. I know that sounds weird because it's chemicals, not people, but you can kind of think of this list as people and ask yourself, will this replacement be better? Will this create a better situation? So something I mentioned in my labs were to look at single replacement like you're taking a lab partner, a lab group, and you're asking yourself, will the new partner be better? Will it want to switch? So you can imagine your activity activity series like a list of students that are ranked in ability. Just hold on 1 second. Okay, sorry about that. All right, back. So think of your activity series like a list of students. The top of the list is the best student in the class. The bottom of the list would be your, I don't like to say worst student, but maybe lowest mark. Maybe they've missed a bunch of labs or something. So just imagine you guys are chlorine. Okay, so you're in a group, you're chlorine. In both of these situations, you're chlorine. You have a partner. your partner is, in the first example, sodium, and lithium shows up. Well, you want to do good in your lab. So your partner is sodium, but you look at lithium. Well, you'll notice that in your list, lithium is the top, the most reactive. Like, you can think of this like the best student. Sodium is a little lower. So again, you're chlorine, your partner is sodium, lithium shows up. Yeah, you might say, well, I want to do really good in this lab, so I'm going to kick out sodium. Sodium's going to have to work by himself, and I'm going to be partnered with lithium because that will be a better situation. So that means this reaction will happen. The lithium joins the chlorine, the sodium gets kicked away by his poor self. Now, in the second example, you are still chlorine, but your partner is zinc. Okay, so your partner is zinc right here, and nickel shows up. And nickel's like, hey, I want to join your group. Can you get rid of zinc? Well, zinc is higher on the list. Zinc might help you a little more. So you're going to stay with zinc. You're not going to let nickel join your group, which means no reaction will happen. All right, so that's kind of like a weird analogy, but that's kind of a good way to think of single replacement reactions. They will only happen if the element is higher on the list. Now, how are you supposed to remember that? Iman mentions in the group they are not strong enough to replace. Exactly. And yeah, Shadan wrote the answer there for the first one. Yeah, that's perfect. So, okay, let's be realistic. You're on your final exam. You might not be able, you can't look at your notes, you can't cheat, but you do have a data booklet. How are you supposed to remember what to do? Well, luckily for you guys, your data booklet tells you what to do. So let me show you, let me explain. You guys are so lucky because you get your data booklet. When I was a student, I had to memorize the activity series, and I had to memorize my solubility table, for example. So let me just open up your periodic table, and I'll show you how easy this is. Okay, so let me share my new screen. Okay, so I'm on page 5 of your data booklet. Look at the paragraph at the top of page 5. Okay, let's read this together. The activity series of metals is used to predict the products of single replacement reactions. Okay, first of all, single replacement. So immediately I know that the activity series, it's not for combination, it's not for decomposition, it's not for double replacement. It is only for single replacement. Okay, so what does it say next? An element higher on the list will replace from a compound an element below it. So it even tells you how to use this list. The only way this reaction will happen is if your element is higher on the list. The table has the most reactive metals on the top and the least at the bottom. All right, did somebody have a question there? I hear somebody's microphone.
So, Mr. Below,
Yes.
it will be no reaction.
Exactly.
But above him, it will be a reaction.
Yep.
And we have to solve it.
Exactly. Yep. Yeah. So if the single element is above, it's on the top of the list, you have to solve this. You have to do the reaction. If it's below, you write NR, no reaction. All right. There's one more catch to this, one more little trick, and we're pretty much done. What if it's not a metal? The activity series here, this list, it only has metals on it. Well, what if you're dealing with a non-metal? Well, for chemistry 1120, we're only going to look at group 7A or 17, your halogens. Okay. Same rule. If fluorine is higher on the list, it's more reactive. Okay. Iodine on the bottom is less reactive. So if the halogen is higher on the list. So like look at my first example here. Chlorine is higher. So this will happen. In this reaction, the bromine is lower. So no reaction. I can almost guarantee you with 100% confidence that on your final exam, you will have some reactions happen, but be careful because we will sneak in a no reaction. So, when you're doing this in December on your final exam, there might be, wink, 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 a no reaction. It could be double replacement or single. And we haven't done double yet. I'll talk about double at the end. So this brings me to this beautiful example here on slide 40. I want you guys to try these, and I'll give you 5 minutes or so. But before you try these, there's a couple of things. When you write your products over here, I want you for full marks. I need the phases or states of matter, which means you're going to have to use your solubility table for compounds. Whoops. And you'll have to use your periodic table for elements. The other thing you need to know for full marks is you need to balance these. Okay, so now again, I mentioned I would talk about this at the end of class, but I will give you a reminder. The ministry is saying the final exam has to be on campus, which means you will do it on paper. So when you're doing this on paper, you need to include phases: solid, liquid, gas, aqueous, right? Solid, liquid, gas, aqueous, and you need to balance it. So that's, like 2, 3, 1, 4. Put your coefficients in there. That's for full marks. If you forget to do a phase or you forget to balance, you will not get a 0. You'll still get a couple of marks. But for full marks, if you want that, 100%, you need to tell me if it's solid, liquid, or gas or aqueous, and include the coefficients, the numbers in front for balancing. So I'm going to stop talking now. I will give you 5 minutes to do this. Now, if you have no idea what to do, just relax, try your best. Try one of these. Maybe if you don't know what to do, you can look and see if one of these are no reaction. I can guarantee you one of these will not happen. So I will stop talking. I'll give you a couple of minutes to try this. If you know what to do, good luck. If you don't know what to do, try your best, and we will do the answers in 5 minutes. Okay, so I'm going to mute myself. I want you guys to try these. Okay, I'll be back in 5 minutes. Good luck, have fun, and if you have any questions, put them in the chat. Okay, answers. How do we do these? Now, some of you put the answers in there. Some of you were, I had some private messages, some public messages, a mixture of good and bad. So let's look. Let's start with A. In question A, we have aluminum bromide mixed with iron. Okay, now, oops, sorry. Iron is obviously a metal, which means I have to ask myself, will iron kick out the aluminum? Again, just imagine that you're bromine, your partner is aluminum, and iron shows up. Is iron the better partner? Will iron replace aluminum? So I go back a couple slides. Hold on, I'm going to clear my writing here. So, because I will have to use this slide as well. Go back to this slide. Okay, so I have iron versus aluminum. Iron, sorry, let me just double check that. Iron is lower on the list. So I was a little bit wrong earlier when I said the barium, the second one was no reaction. Iron is lower on the list. Well, I guess I'll write this on the other slide. So if I go back to this question, iron is lower. This means no reaction. Iron can't replace aluminum. Iron is too low on the list, so it won't happen. I'm done. No reaction, nothing happens. Finished. Halas. You don't need to balance this. You don't need to include phases. Nothing. No reaction. Iron is lower. It will not replace the aluminum. All right, let's go down to question B. Here I have barium versus sodium. Again, like think of this like a competition. Barium versus sodium. Who wins? Can barium kick out the sodium? We go to our list. Okay, sodium is here. Barium is here. Guys, if you forget the names, you can look at the elements as well. This is a good hint, by the way, wink, wink. If you can't remember the names of some of your metals, so you're on your final exam and you can't remember what tin is, it's actually written on this in your data booklet. So there's ways around learning chemical names on your final. Again, if you can't remember what platinum is, it's here. If you can't remember what gold is, it's here. So the data booklet is truly amazing. Anyways, back to this question. Barium, obviously higher on the list. So barium versus sodium, barium is higher. Barium wins, so barium will kick out sodium. So that means I'm going to have a compound of barium and bromine and sodium on itself or by itself. Now I'm going to make a mistake here. I'm going to write barium and bromine together. That's not correct yet, but I will write the sodium over here all by himself. Sodium is a metal, so it's solid. The only metal that's a liquid is mercury. So I know that any metal is going to be solid except mercury. Now I got a problem here. BaBr is not a chemical. It doesn't exist, not normally. Ba is in group 2, so it's 2 plus. Bromine is in group 7, so it's 1 minus. This is review from chapter 3, and Abdul Halim gets it correct. Ba2Br. Iman has a question. I'll come back to your question, Iman, in a minute about lithium and water. But yeah, Abdul Halim, correct. The formula here is Br2. Crisscross method, right? So I have 2 bromines with 1 barium. This is review from chapter 3. So you guys should be pretty good at this already. Now, there are 2 things left for full marks. First, what is the state? Barium bromide, is this aqueous or is this solid? Will it be a precipitate or will it be an aqueous solution? And second, I need to balance this equation. So first things first, let's look at our good old friend, the data booklet. My best friend in chemistry. Without the data booklet, I wouldn't be able to do half of this stuff. All right, now you can see from my last class, I had all this written here, but we'll pretend it's not there. Bromine, I'm combining bromine with barium. Most chemicals with bromine are soluble. Barium is included. Now, how do I know that? The insoluble chemicals are on the bottom. That includes chromium, copper, silver, gold, mercury, lead. Barium isn't there. Barium, therefore, with bromine must be soluble. Okay, so back to my notes. I can write aqueous here. And now I'm ready to balance it. And luckily for us, this is a pretty easy equation to balance. So I have 2 bromines, so I'll put a 2 here. That means I have 2 sodiums, so I'll put a 2 there. Full marks. Not an easy question, but full marks. There you go. Phew. Okay, one more, and then like I said, I'll introduce the next section and we're done. Now, in the class before you, I had a lot of students get C wrong. What happened? C, I thought C would be pretty easy, but I think people forgot the slide before. So let's look at C. In C, I'm dealing with a non-metal. So the non-metal can only replace the other non-metal. You can't put non-metals together or metals together. So really, step number one here, you ask yourself, this is a fight. Who will win? Will will fluorine beat chlorine? That's the question. Will fluorine beat chlorine? The answer, of course, is in your data booklet. Fluorine is the highest. Fluorine always wins. Chlorine is lower. So yeah, fluorine will totally kick chlorine out of this reaction. As Abdul Halim says, yes, because it's higher. So this is a reaction. In this fight, fluorine wins. Cool. All right, now this is a pretty easy one. These are all halogens. Halogens are all the same chemical, like they all have the same formula or same ionic formula. Come on, dog. Don't be barking. Okay, so I'm going to get BAF2. Now, how did I know it was BAF2? Well, I'll come back to that. Then I will write Cl2. Poor old chlorine gets kicked alone. Remember, halogens are always 2. F2, Br2, Cl2. Where did BAF2 come from? Well, barium is 2 plus. F is 1 minus. Easy. Crisscross method, BAF2. All right, you just got a mark. Just by doing that, you got a mark. For full marks, though, we need to balance this and include my phases. Let's get the easy phase out of the way. Chlorine, it's an element on the periodic table. And chlorine is in this color. So these are gases, this is a liquid, and this is a solid. Anything white in the periodic table, solid. Anything blue, liquid. Anything orange or pink, gas. All right, so this would be gas. Now, what about this guy? I'm going to be honest, this surprised me because, like, again, when I was a student, I had to memorize this. Now you guys can use your data booklets. Another question from Aman, I'll come back to that one as well. So that's 2 questions I'll come back to. That's a good question as well. Okay, so what about this one? What do I do? Help, I don't know what to do. Well, it's a compound. And anytime you see a compound, you need to look at your solubility table. So I'll go to my solubility table. Here it is. I'm dealing with fluorine. Now, I honestly, if you gave me this on a test and I didn't have my data booklet, I would have said barium fluoride was soluble, aqueous, but it's not. Most fluoride compounds are soluble, but lithium, group 2, barium is in group 2. Sorry, I got too excited there. Barium is in group 2, meaning it's insoluble. Right? Guys, if any of you ever need help with solubility table activity series, don't forget you can always send me an email and meet me. We can have a one-on-one Zoom meeting. So anybody who's not sure why that this is a solid, this is something you need to know. So you can always send me an email, say, hey, I'd like to meet with you, and we can pick a good time for Zoom. I can even meet you in the evenings. I don't care. I got nothing to do. I can't leave the house. So anyways, now for your last mark, I need to balance this. This is already balanced. Not every question needs to have numbers in front of them, guys. Some chemical reactions are balanced. I have 2 fluorines, 2 chlorines, 1 barium, everything's good to go. You will definitely definitely get something like this on your final exam. Okay, so there are worksheets on this with answers. Check, you will see this again. And I mentioned to the other class, oh, the way that I'm going with time, sorry guys, I will have hold on. Sorry, that was crazy. Somebody in the hallway. Okay, what I said was, like I mentioned to the other class, the way I'm going with my time, we will have a couple of classes at the end of this semester to do review. So, at least 2 classes, I think we can do a review. So, come with some questions. This is tough. This is not the easiest topic. So we'll practice this a little bit at the end. Oops. All right, guys, I'm pretty much done. I just want to introduce us to the next part. Oh, and I should answer Aman's questions. So 2 things. Aman asked, what will happen when you add lithium to water? That's a little bit more of a question we wouldn't do in this course. It's a very exothermic reaction. It would release heat, kind of like when we mix sodium with water. But in terms of this course, you wouldn't have to do something like that. We're focusing on simple reactions. If you're curious, lithium and water would produce lithium hydroxide and hydrogen gas, but that's a little bit outside of chemistry 1120. We're sticking with kind of the more basic reactions. But I know why you asked that, because lithium is a metal and there's no metals in water, but not something in this course. The other question was about noble gases. We don't have to worry about noble gases because noble gases don't react. So you will never see a question here with a noble gas. They're basically non-reactive. There are ways to make them react, but not something you worry about in chemistry 1 or chemistry 2. All right, the finale of today. I have another class I got to get ready for, but I just want to set this up. A double replacement. This is a single replacement done twice, meaning 2 elements will switch. The easiest way to think about a double replacement is to pretend you have partners again. So you're in the lab, you have a lab group, it's you and another student. And there's another lab group, it's me and somebody else. A double replacement is when we switch partners. So group A has 2 people, group B has 2 people, and they switch partners. So in this example on slide 41, what is it? I think A and D kind of switch. Yeah, A and D here are like swapping partners. So A joins with C, D joins with B. Okay. This is a picture from a book. It's not really the best example, but I will show you some examples tomorrow. Metals will always switch with other metals. And the important thing here is the strength doesn't matter, meaning no activity series needed, because no elements are being left alone. In a single replacement, you're leaving an element by itself. So you need to see, would this happen? Are you going to kick out your partner and make somebody work alone? Well, you need the activity series. With a double replacement, if you're just switching partners with another group, the strength doesn't matter. What does matter, and this is something I wish I had have known when I was a student, is what kind of products will you get? So how do you know a double replacement happens? Well, if you do a double replacement and one of your products is a solid, or one of your products is a liquid, or one of your products is a gas, it will happen. We will talk about this tomorrow in greater detail, but this is a good little hint to get you ready for tomorrow. When you look at a double replacement, if there's a solid, liquid, or gas as a product, it's going to happen. If your product is all aqueous, no reaction. So if all of your products are aqueous, no reaction. But the minute you see a precipitate or a gas or a neutralization, which makes liquid water, it's going to be a reaction. And I will talk more about that tomorrow because it is 3:16. I do have another class to get ready for. And I mean, this was enough for today. Okay, so that's it for me today. Yes, Abdul Halim, there was one with H2O in the lab. For anybody who's already done the lab, the last experiment had H2O. It was NaCl plus, no, sorry. It was NaOH plus HCl. We'll talk about that more tomorrow in class. All right, guys. So if any of you have any questions, let me know. If you guys don't have any questions, you're free to go. Thank you, Naval. Oh, thank you, Fahad. And sorry, earlier in the class, I had a question about the final exam. Again, thank you, everybody. But your final exam will be after December 6th, and it is on campus, and we will take social distancing measures. So there'll be masks, students will be spread across like maybe a gym or a lecture theater, or a classroom. We might only put like 10 or 12 students in a full classroom. So just keep that in mind. Your final exam is on campus. The ministry is making or is telling us to have it on campus, and we will take social distancing seriously. And it's after December 6th. Thank you, Shadan. Thank you, everybody else. I'll stick around for a minute if you have any questions.